Let's start with a new section, Sockets. In this section, you will learn about the basics of sockets. A socket is a one endpoint of a two-way communication link between two programs running on the network. A socket is bound to a port number so that the TCP layer can identify the application that data is destined to be sent to. An endpoint is a combination of an IP address and a port number. In layman's language, think of it as a gate out of thousands of gates in an apartment. The primary purpose of socket is to connect one of the endpoint of a pipe to the end user, that is an application. To identify a socket, you have to mention two primary things, IP address and a port number. As you can see, in a simple one-to-one network, a system usually has a single IP address to which all the endpoints of a program connect. Port number comes in handy in identifying socket for specific application, service in an application. A unique combination of both is used to identify a socket. At any point of time, application can create or possess multiple sockets, which can perform different operations like sending or receiving data from others. A socket is a unique identifier of an application in a network. An application is just a program running on a device. That device is identified with its IP address unique in the network. The application is identified with a port number unique within that device. If you combine both, you will identify the application over the internet. On your screen, you can see the socket is written as IP address : port number, like 172.217.7.238:80, where 80 is the port number. In this diagram, you can see application 1 sends the data to IP number 192.168.16.21 of application 2 with port number 100, while application 2 sends the data to IP number 192.168.1.1 of application 1 with port number 80. In simple terms, think of your house as a system and you are the application in it. Now, you want to send a letter to your friend in another house. Let's suppose he is in some other state. What you would put on the envelope is his name and address. Now, his home address can be considered as the IP address via which we can identify the system that is home uniquely. But the application, that is person to which that information is sent, is identified by the socket, that is his name. The socket name uniquely defines the application, that is the person. Because sockets are the means by which computers on a network communicate, they open your computer to attack. The simplest possible attack is denial of service. Another common attack is to exploit a vulnerability in a particular program listening at a port. Sometimes it's possible to trick a listening server program into allowing unauthorized access to that program or even the whole computer. The hacker either wants data on the server or wants to use the machine as a mule, that is to launch further attacks from that machine. On your screen, you can see socket structure. I am not going into the deep of socket structure, but I will give you an overview of what is a socket structure. The socket structure consists of 5 fields. The first is family. Family field is used for defining the protocol such as IPv4 or IPv6 or other Unix domain protocols. Type. This field is used for defining the type of sockets such as stream socket, packet socket or raw socket. Next is the protocol. This field is usually set to 0 for TCP and UDP. Local socket address. It is used for defining the local socket address, that is the combination of local IP address and the port address of local application program. Remote socket address. It is used for defining the remote socket address, that is the combination of remote IP address and remote port address of a remote application program. Let us have a quick recap of what we learned in this lecture. We started with the definition of socket. Then we saw the importance of sockets in computer networking with a real-life example. At the end, we had an overview of socket header. What's next? Next is a completely new section, the application layer protocols.